Hello everyone, and this is Anastasio here, and welcome to my YouTube channel. In this video, we will be discussing about the ideal reheat cycle. The main purpose of reheating is to further utilize the steam given enough pressure, but due to the quality of the steam declines to a certain value that is harmful to the turbine, say 90%, reheating it to a higher temperature and further expanding it to another lower pressure, those making use the remaining pressure to work. As we know, the lower the quality of the steam, the greater the liquid content. Thus, as it collides the turbine blades, it may cause corrosion and are harmful to the turbine. Reheating process is the solution to the problem, so sit back and enjoy learning the process. So it looks like this. We have starting of point 1, pressure 1, T1. This point, this is your point 1, pressure 1, and T1 here. Okay, in the TS diagram. TS means temperature and entropy. So you can find your H1 and S1. Now, in the assumption of ideal cycle, the steam expands isentropically, meaning from the point as it enters and exceeds at point 2 at pressure 2, S2 is equals to S1. So this is your point 2. Now, we can see in the diagram that what's happening is that as it goes downward, it goes farther downward, it may be pause or it may cause danger to the turbine because of the accumulation of liquid in the vapor mixture. So to utilize the pressure and to utilize more to gain more energy or work without compromising the safety of your turbine blades, we will use and reheat that to the steam generator. Okay, but before that, let us first have this one. We have point 1, temperature 1. We can find enthalpy 1 and entropy 1. At point 2, pressure 2 with S2 equal to S1. We can find, okay, if you feel that the value of your SG, or if you see that the value of your SG is greater than S2, then you look into the saturated table. However, if your SG is lesser than S2, you look at the superheated steam table and interpolate. So at this point, and in this illustration, we mean that Sg is greater than S2, such that S2, which is equal to S1, is equals to SF2 at pressure 2 plus X2 SFG at pressure 2. So we can find the X, the value of X2. That is why H2 is equals to HF2 at pressure 2 plus X2 times SFG2. Those we can find the H2. Now, as the steam enters back into the steam generator, we are assuming that the process is isobaric, meaning constant pressure. And the only thing that is happening is that the change of quality until such the quality becomes saturated gas or saturated vapor, and the further addition of heat will turn it into superheated vapor. Okay, so we have 3 here. Okay, further addition of heat, uh, the remaining liquid will turn all into vapor, and all values becomes saturated vapor, and further addition of heat becomes, say, at point 3, superheated mixture or superheated vapor, not the mixture. Okay, superheated vapor. Those we have another value that is P3 is just equal to P2. Okay, and another temperature 3. So this is your point 3. P3 is just equal to P2 since isobaric. We're talking of isobaric process, and we have your T3. Those we may find or we can find H3 and S3. Okay, at pressure 3. Now, okay, we draw a line here, and then we let the steam expand to point 4 at pressure 4, where the fourth state is that P4, and we assume that it is isentropic process because it is ideal. S4 is just equal to S3. Okay, at this point it expands something like that. This is your point 4. Okay, so that means we have to find the value of your H4. But again, we take note that if S4, which is equals to S3, greater than S, say G, okay, look at this in this table, we are reversing it, okay, so don't get confused, okay, we are reversing the value, or we say SG is greater than, I mean, lesser than S4, which is equals to S3, then it is superheated. But if your SG is greater than S4, which is equals to S3, then it is saturated. So if it is superheated, you have to interpolate. You have to plug in the the SG value or the S4 value. Okay. I have attached the video about how you will interpolate, the process of interpolation or double interpolation in this video in the description below. So therefore, we will find the X4. So S4 equals to S3 is equals to SF3 plus X3. I mean S4, X4, SFG4. This becomes what? X4. We can find the X4. The value of X4 again. We will find the H4, which is equals to HF4 plus X4 HFG4. Okay, so at this point, I think the pressure is enough. And by the way, we are producing work from turbine work turbine 1 to 2, and work turbine 2 to 3. Oh no, 3 to 4. Okay? So there are two turbines involved in here. Then we reject heat from the condenser QR. So QR is just equals to H4 minus H5. So the H5 is here. This is the 0.5. This is the 0.5, where H5 is just equals to HF at pressure 5, but pressure 5 is equals to pressure 4. Okay? So therefore, right here, to be clear, I would erase this so that it will not go making smudge in that. It's clear. So therefore, pressure 5 is just equals to pressure 4. Since we are talking of condenser, an isobaric process. And H5 is equals to HF at pressure 5, which is equals to pressure 4. Okay. We also want to find the V5, specific volume, where V5 is equals to VF at pressure 5, which is equals to pressure 4. Okay. So therefore, the work of the pump is just equal to V5 times, okay, we look at this from 5 to 6. And we all know that pressure 6 is just equals to pressure 1. Since we're talking about the boiler, it is an isobaric process. So pressure 6, which is equals to pressure 1 minus pressure 5, which is also just equals to pressure 4. Okay? So therefore, the value of your 6, H6 is equals to what? H5 plus work of the pump. Okay? So this is your isovolumetric process. This is your 6. We are applying work of the pump here. Like that. Those. It is now complete. The data is now complete. So we need to find the work of the total turbine, which just equals to work. Sorry. Okay. Work turbine is just equal to work turbine 1 to 2 plus work turbine 3 to 4. Work net is just equals to work turbine total minus work pump. Therefore, also I forgot to find that the QA is equals to H1 minus H6. So therefore, your thermal efficiency is equals to work net over Q, or heat applied. So this is now your preheat process. So in the next video, I will be presenting also the regenerative process. And in the next video, I'll be combining the reheat regenerative process, both open and closed feed water heater. Thank you for listening and have a great day.